Hi, so I'm going to be talking about question number 27 from chapter 6. So the question says, a small piece of styrofoam packing material is dropped from a height of 2.00 meters above the ground. Until it reaches terminal speed, the magnitude of its acceleration is given by A equals G minus BV. After falling 0.5 meters, the styrofoam effectively reaches terminal speed and then takes 5 seconds more to reach the ground. A. What is the value of the constant b? B. What is the acceleration at t equals 0? C. What is the acceleration when the speed is 0.150 meters per second? So here's the work. So first I drew my little diagram, which is just a little piece of styrofoam going downwards at 2 meters. So for the first part, we first calculate the terminal velocity, and so we know that it's falling from a height of 2 meters and that it's traveled 0.5 meters before it reaches its terminal velocity. So we subtract that from 2 meters, its total, and divide it by how many seconds it takes to reach the bottom. So we find that the terminal velocity is 0.3 meters per second. Then, since at terminal velocity acceleration is 0, we use the equation that they gave us, A equals G minus BV, and we solve it and use some algebra to convert it to B equals G over V, and we use gravity, which is 9.8 meters per second squared, divided by 0.3 meters per second, and we get 32.7 seconds to the negative first power. And this gives us the answer to A. Then for B, the question is, what is the acceleration at t equals 0? So the acceleration at t equals 0 is just the gravity working on it. So that would just be 9.8 meters per second squared downwards. And C asks, what is the acceleration when the speed is 0.15 meters per second? So C, we just use the equation that they gave us. So acceleration equals gravity minus the constant times velocity. We know gravity. We subtract that with the b that we found in part A, and we multiply that by the velocity that they gave us, and we find that acceleration is 4.895 meters per second squared. And that is the answer to C.